Assalamualaikum dear, welcome to our channel Civil Technology 106. Today we are talking about maximum bending stress and beam. We have a beam 20 cm depth and 10 cm wide. We have to determine the radius of curvature and also the maximum bending stress. This is the depth of the beam, 20 cm. Given data, depth of the beam is equal to 20 cm, the distance from the top of the beam to the bottom. This is called depth. We have depth 20 cm. Breadth of the beam is equal to 10 cm. Yes, it is. Maximum bending moment is equal to M. M is equal to 500 kilonewton meter. Is equal to 500 kilonewton we have in meter. We have to convert N to centimeter. So 500 multiplied with 100. When we do some maths, we will get 5 multiplied 10 raised to the power 4 kilonewton centimeter. Young modulus. Young modulus is the ratio between stress and strain. This is also called coefficient of elasticity. Young modulus we have 200 multiplied 10 raised to the power 9 divided by 1000 multiply 100 raised to the power 2. So is equal to 2 multiply 10 raised to the power 4 kilonewton per centimeter square. Required data. We have to record some items, which is a maximum bending stress. We represent the maximum bending stress and F. We will determine it now. Radius of curvature is equal to R. We represent radius of curvature by R, and also we determine it now. This is a figure. Solution. Distance of extreme fiber from NA is equal to Y. We determine it by Y. So Y is equal to D by 2. D is the depth of the given figure. Yes, it is 20 centimeter. So divide by 2. 20 divided by 2 is equal to 10. Also to determine the moment of inertia NA. So moment of inertia represented by I. I is equal to BD cube divided by 12. B, we have the breadth of the given section, and D is the depth of the given section, which is of course 20 centimeter divided by 12. So when we do some maths, we will get 6666.66 centimeter per. We have to determine the maximum bending stress and also the radius of curvature. Now we have ready to put the value in this equation. This is called bending equation. So we need F, maximum bending stress. So that's why we take from this equation two part. M over I is equal to F over I. We need F, so we multiply Y with both sides. So Y cross with Y. F is equal to M over M multiply Y divided by I is equal to M. We have 5 multiply 10. Yes, it is. We find that a few minutes ago. 5 multiplied 10 raised to the power 4 kilonewton centimeter. And y, also we determine the y, which is of course 10 centimeter. Divide by I. I is the moment of inertia. We also determine it now. Recently we determine it. So 66.66 centimeter per hour. When we do some math further, we will get 75 kilonewton per centimeter square. This was maximum bending stress. Now we have to determine the radius of curvature. So now we take two parts from this equation. One is mi. We ignore f over I because we have to determine the value of r. So that's why we take E by R and M by I. We have to determine the value of R. So we multiply both sides by R. R cross with R. So E is equal to M by I is equal to R multiply M over I divided by M over I to find R. M over I cross with M over I. R is equal to E over I, E multiply I divided by M. So R is equal to E multiply I by M is equal to E is we find it already. 2 multiply 10 raised to the power 4 multiply I we have 66.66 divide by M we have 5 multiply 10 raised to the power 4 is equal to, when we do some maths we will get 26 16 66.66 centimeter. Yes, it is. This was our approach. We done it. Thanks guys. Thanks for watching. And wassalam. Subscribe our channel for more videos.